Hello, hello, and I finally have another pedaling pianist puzzle on the channel. It's been a while, and this puzzle is called Chocolates. And I did my best to butcher the rules to fit in that little box, but I'm going to read the rules as they actually are and not what's in the box. So if they're a little bit out of order, I apologize. That's just the way it's going to go. So this is a chocolate banana puzzle. I don't think I've actually ever done chocolate banana puzzle. We'll see how that goes. But basically, we're going to shade some cells, and I did in advance make a little brown color, and so the to be chocolate. So we're going to have essentially, I'm going to color all of the cells, and the ones that are described as shaded, I'm going to label them brown, and maybe it'll look like this. And these shaded cells have to be in a rectangular pattern. So I couldn't have, say, another brown cell here unless I were to extend it to form a rectangle. So it has to be, I can't have anything weird like this in my chocolate regions. But banana regions, which are yellow, specifically can't be rectangles. So I'm going to have different sets of connected, different connected little colored regions. And if they're a rectangle, they'll have to be brown. And if they're not a rectangle, they'll be yellow. Hopefully that made sense to you. Cocoa chaos construction. Find 6 non-overlapping or orthogonally connected 6-cell regions such that any chocolate bar or banana is entirely contained within one single region. Okay, so first of all, that's going to tell us that none of our regions are more than 6 cells. Second of all, that's going to tell us that the regions can all be added to other regions to make groups of 6. So for example, if I had a banana that looked like this and a chocolate that looked like this, well, first of all, since this chocolate would be 6 cells, that would be that would be one of the regions, one of the 6-cell regions. And then this cell would either have to grow, right? Maybe the banana goes like this, and so it's now a 6-cell banana region. Or maybe I could put another chocolate region here. And then these, well, this wouldn't work, but anyway, suppose it could. This is going to, these two regions together could make up one of the 6-cell regions. And those 6-cell regions are going to be chaos construction regions, meaning that the digits 1 to 6 are going to repeat once each as well. And in addition, every row and every column are also going to be the digits 1 to 6 once each without repeats. Banana balance. The sum of all shaded cells, so that's the chocolate cells, is equal to the sum of all unshaded cells. That's the banana cells. Okay, so it's not that the number of cells is the same, it's that the sum of them is the same. Okay, I'll try to remember that. That's, I mean, when I read through rules, I try to think, well, what's the rule I'm going to forget? And I think that's the one. Circles. A digit in a circle, including between line circles, so I guess this is a between line. So these 6 circles show the total number of cells in that chocolate bar or banana. Oh, okay. So, I mean, that tells us what that is, but let's take here. Suppose this were a chocolate bar, a 2x2 chocolate bar. Then this would be a 4 because this, being a chocolate bar, would be combined with this 2x2. Additionally, the circles represent an extra region, i.e. they contain the digits 1 to 6 once each. And I'm now realizing that I have another rule that I didn't even put in the description, but that's fine. I'll just say there wasn't any room in the box anyway. This is a between line. So digits on this line, so these 2 digits, must be strictly between the digits on the circles in the end, but they may repeat. So for example, this could be 2, 2, 1, 3. That's a valid way that this between line might work. What's not valid would be, say, 3, 5, 5, 2. Because these are the same, so these digits are not strictly between the max and min of those 2 circle digits. Those are the rules. Let's try it out. So I said before, I know what this is because these are all different digits. And what I was thinking about as I was thinking about what the implications of that were that if any of these circles were in the same region, they would have to have the same number, right? So if this were a chocolate bar, 3x2 chocolate bar, then since these are in the same region, they describe a section with the same number of elements, namely 6 in this case. And so both of these would have to be a 6. And since the circles all have to be an extra region, they can't have the same digit in them ever. So none of these are in the same regions as the others, which means this cannot grow. This has to be a region by itself, and a 1 by 1 region is in fact a rectangle, so it's going to be chocolate. And since this is chocolate, I don't know if I said this. Well, I guess that's not explicit in the rules, but I've seen other people solve chocolate banana puzzles, and one of the results in a chocolate banana puzzle is that if I figure out what a region is, then all the edges of it have to be the other region, right? Because I mean, just very clearly, if this were chocolate, the chocolate would continue on to grow. So kind of almost definitionally, I mean, not almost, exactly definitionally, once I know that the region ends, then the next cell over has to be the other thing. So these are going to be bananas. And now because these are all different regions, this can't be banana or it would connect all these. So this is also chocolate. Um, and these must be banana because the bananas can't be rectangular. And now these have to grow more. So this one in row 1 has to get to row 2 at least. This one in column 1 has to get to column 2 at least, but they don't necessarily have to do so here. In fact, they can't both do so here because that would make another one chocolate bar region, which we cannot have. So what do I know about this? So this is, well, actually, what I know about this is either 2, 3, it's not 5. Oh no, it could be 5 because I could have a chocolate bar. Well, no, it can't be 5. So I was going to say this has to be a valid rectangle size, which means it's 2 or it's 3 or it's 4, it could be 2 by 2, or it's 6, it could be 3 by 2. I was thinking 5 is prime, so it doesn't work for some reason, even though 2 and 3 are prime. But I wasn't thinking that 5 could just go a 5 by 1 in some orientation. But if I do that, that's going to break a banana region because if I do this, this banana will always be a rectangle. So this actually can't be 5, but for reasons I didn't quite understand. And these can't be 2 because they have to grow. So these are at least 3. Can I say something about these? Probably not. Okay, now I'm thinking, could this possibly be chocolate? I think the answer is no, but it's hard. I mean, because of this, right? So maybe it could. Maybe it could. I was thinking if this is a 2, well, it could just be a 4 chocolate like this. That seems pretty plausible as well. Yeah, I don't know. I don't know where to go from here actually. Um, I don't think I can do anything with the banana balance rule yet. Maybe. Um, what do I do next? So these, since the lowest this could be is the circles can be now is 2. These are between 3 and 5. Maybe I think about where the 6 goes, but I feel like 6 could go really anywhere. Um, do I think about where the 1 goes? No, I don't think I can do any Latin square logic yet. Maybe I think about regions, right? So this, whatever region this 1 is in, is going to absorb one of these bananas because it's got to grow, or the chaos construction region, I mean, it's got to grow. So it's going to go either to here or to here. And it could grow. I was thinking it couldn't grow to one of size 4 because then I would need another 1. But that's actually fine. Like I could do something like this and then another chocolate 1 here, say. As this and this. Oh, well, not here, I guess. But here. I mean, here doesn't work for complex. Oh, maybe it does work. No. Oh yeah, this could be a chocolate. This could be a 1 by 1 chocolate cell that doesn't have a 1 in it. So yeah, something like this could work actually. Right. Yeah, it's only in a 1 by 1 chocolate cell doesn't have to have a 1 on it. It's only because there's a circle here that has a 1. These digits are between 2 and 6, of course. And I was trying to say something like, well, could it really be 4? But I think it could. You could have 2, 4, 3, 3, or 4, 6, 5, 5. I think that's fine. So what am I supposed to do next? I really have no idea. And I mean, how does the symmetry break? It's got to break by this. But I don't see how we can do anything with that yet. Maybe I can rule 3 out of these. Like if this is a 3, it has to do that. Is that a problem? These become chocolate. This becomes chocolate. This becomes chocolate. Actually, yeah, no, that does break immediately. So, yeah, so if this is a 3, then this has to be banana, and that's the whole banana. Because so it's got to grow to 3 cells. Where does it grow? It can't go to here, that's chocolate. It can't go to here because then we have a rectangle, so it's got to go to here. So that becomes banana. And because this is the full banana, anything it's adjacent to has to be chocolate. But now what is this cell? Well, this isn't a 1, so this has to grow. And now I have a non-rectangular chocolate. So it just does not work. And I think, I haven't looked ahead yet, but I don't think, I think that's going to fail here too, right? If this is 3, it's the same problem. Yeah, these are chocolate, this is chocolate, and this makes a chocolate regular region. That can't be 3. Now, if this is 4, I could do something like that. 2. This becomes banana. And that's okay. Well then. Okay, now I'm thinking about this one connecting this banana, and now it's actually, because wherever the one connects, I knew this before, I don't think I said it, that it can't connect to a 6, because if it connects to a 6 in the chaos construction region, if it connects to a 6, I'd have, because each chaos construction region cannot split either a banana or a chocolate. This, wherever the 6 is, has to be its own region. It can't combine with any other bananas or chocolates. So 1 and 6 would be 7 cells in the same region, wouldn't work. I could do 1 and 5, that's very natural. 1 and 4 it's possible, but then I need another 1 by 1 chocolate region, which doesn't have to have a 1 in it. But all that's telling me is at least one of these is not 6, which is not helpful, really. I don't know how to mark anything I just said. Could this be 6? The only way it's 6 is if it's this. If it's 6 like that, no, that also breaks. That's hard to see, but this breaks. So this can't be a 6 because, well, so first of all, if it's 6, it can't be a 6 by 1 because a row and column thing are taken. So it's got to be a 2 by 3. I can't do this because then we will have 2 chocolates, 2 circles in the same bar. I can do this. This is the only thing that would work. So if it's a 6, it's like this. Now, what's the problem with that? The problem with that is that these now would have to grow, and they can't grow into the chocolate bar, and they can't grow into this circle, because if they go into the circle, I'll have the same problem of 2 circles in the same banana, which is a hilarious sentence, but still. So these have to be at least size 5 each, which means they'd be 5 and 6, but my 6 is already gone. This is not a 6. I bet it's going to be 2, but I don't think I can really eliminate 3 and 4 yet. And the nice thing about 2 here is it will get rid of a 3 down here. And I would need a 3 or a 4 and a 5 or a 6 in here. Okay. Maybe I can say, is there any way this doesn't grow? So is there any way this grows in? Like, could this be yellow? Because that actually forces a lot of things. If this is yellow, this chocolate bar is a 2 bar now, immediately. So this has to grow. This also has to be banana, so it would have to grow further to here. This would also be banana. Oh, and this would be banana. Yeah, no, that just doesn't work. This can't be a 2 bar like this. So this I think it's easier to see in multiple steps. If this is a 2 bar, it goes down. It would have to grow down, which means it does grow down. So this is it. This can't grow to the right only. Right? What happens if it does? If it grows to the right only, then immediately we're saying this is a 2. And then the adjacent things have to now be banana. This has to grow, so it's banana, and now I have 2 circles and the same banana. It just doesn't work. So this has to grow down, which means this has to grow. And now, can I say this is not a 2 by 2? Yes, this is not a 2 by 2 for the exact same reason. If this is a 2 by 2, this is banana, and this banana has to grow. So this doesn't work. So this could be 4, but it's going down this way. So this is banana. And therefore this is banana. So this chocolate bar goes as far as it goes, and as far as it goes, this banana is going to grow as well. And now this digit is kind of interesting because it's not this digit, and it's not either of these digits, and it's not 1. So this digit is one of these two, because this has to be between these two. And since it's in the same banana as here, it's in the same chaos construction region. So these are different digits. It's not a 1. So this is either one of these. This is one of these 2 digits. I don't know. Can this be chocolate? Now, if this is chocolate, I think we're going to start getting problems. Because if this is chocolate, well, hold on, let's do this. There's no way this is chocolate, right? Yeah, because then I'll get 2 6s, right? I'll get 2. So if this is all chocolate, these all become banana, and then we get a 6 banana here and a 6 banana here. These 2 are 6s, and that violates our circle rule. So this is not a 4. This is either a 2 or a 3. 3 might still be possible. This could be 3, 5, 6, or something like that. These could be 2, 4, 3, 3. Yeah, in fact, that seems pretty likely. Let me just think a little harder about that. Because if it's 2, it just works very easily. Which makes me think that's not true. Although if I can somehow show that one of these has to be 2. Well, okay, so let's do the easier thing. This can't be in this banana, so it's chocolate. And it's not 1, so it has to grow. It could be just a 6, I guess, though. Yeah, in fact, if I could show that one of these had to be a 6, I don't know how I would, but if I could show that one of these had to be a 6, then that immediately gets rid of 5 from here and 6 from here. This becomes a 4 or 5 pair. This will become a 2, 3 pair. Oh, that helps. Okay. Can this be a 3? If this is a 3, this is a 3. I don't know. Hold on, what does this combine with? Maybe that's what I need to think about, because if this becomes 3, it can't combine with either of these regions in the chaos construction sense. Like, whatever this is, it's going to combine with a banana of some sort to form a 6-cell orthogonal chaos construction region. But this is going to be surrounded on all sides by these no matter what, I think, right? Because if this is a 3, this becomes chocolate, these become banana, this becomes banana, and this will be connected to this necessarily. This banana will have to connect to this because this has to get to row to column 2 somehow. And I can't do it over here without touching this. So there's no way to get, the only bananas this region is going to border are these two. And if this is 3, it's going to combine with the region of at least size 4 to make 7. That doesn't work. This has to be a 2, which means these are not 3. This cell is this cell, which is 4 or 5 now. This is banana. This 2 is going to connect with a 4. And then this will have to connect with the other one, which is not a 6. Because, yeah, so 2 is going to connect with 4, and 1 is going to connect with 5. I don't know which way is which yet, but that is it. That's really big. Because now, so this is either done or it grows by 1. It can't grow to here because that will connect these. So this is chocolate. Can this be banana? Maybe. This is at least 3. In fact, these are 3 or 6. These are 3 or 6. This could just be a chocolate like this. Now, can this be banana? I think the answer to that is no. But let me be more careful about why. Yeah, this can't be banana, because if this is banana, that's going to be the end. This can only grow at most once more. So if this is banana, that's our banana region, that's it. That means this is chocolate, this is chocolate, this is chocolate. And now, in order for these not to connect, and if they do connect, they'll form a non-rectangular shape. And so if they can't connect, but if they don't connect, this is banana, and it's a 1 by 1 banana, which is in fact a rectangle, which is not possible. So this is chocolate. So this is not chocolate, because that'll be a non-rectangular region. So this is banana. How is this going to keep going? How do I keep this going? Well, this is not 4 or 5, actually. I know that. Well, first of all, these are 2 different digits. That's the easiest way to see it. These are in the same banana, so they're different digits because each banana is within its own chaos construction region. So it's not 2, it's not 4 or 5. This is 1, 3, or 6. It's probably 1, right? It's probably 1. I don't know. Could this be a 3 banana? Maybe that's hard. How would I do a 3 banana? It would have to be something like this, which would probably break. I don't know. Maybe it's this cell. Can this be banana? If this is banana, then that's it. This is chocolate. This is banana. Yeah, that seems okay. Could this be chocolate? Maybe this can't be chocolate. If this is chocolate, what happens? This is banana. But this could just do that. Yeah, no, that fits quite well, actually. Okay, how would this be a 6? Because this can only grow at most once more. So I've got to be careful about the way I arrange this to not kind of expose too many extra banana cells that would attach to this. So for example, like this couldn't be a 6 cell region because these would all be banana, and that would make too large of a region. So we couldn't have a 6 cell like this. We couldn't have a 6 cell like this. We could have a 6 cell like this. We could not have a 6 cell like this. So if it's a 6 cell region, it does this. Oh, but if it's a 3 cell region, I think we're gonna get the same thing, right? It couldn't go down like this. It could do this. It couldn't do this. So what we get actually is these are all chocolate. No matter, I don't know if it's 3 or 6 yet, whether this repeats, but these are all chocolate, and this is now banana. And this is my 4. So this is my 5. This is a 5. This has to grow to here, which is banana. This is now chocolate. This is now banana, which goes to here. I still don't know if this is 3 or 6, which way is which is incredible. But I do know that this 1 now connects to this 5. And so this cell, whatever it is, I'm going to call it A, repeats here, because this 6-cell region has address 1 to 6, and this 6-cell row has the same. These are all the same between those two 6. So this is A. That's just kind of basic irregular sudoku, right? This is a 6-cell region. This is a 6-cell region. The only difference is these two. And this is also a 6-cell region. So this is 3 or 6, 1, 3 or 6. These could connect. I mean, this could be a little triangle here. Could they be a little triangle here? Maybe not, but it doesn't. I was thinking if I do this, I end up with, it makes it very difficult to finish this off with chocolates and bananas. Because this would all be banana. And the bananas can't be too big. These would all be banana. These would all be chocolate. I mean, yeah, that is tough to, well, no, I could do something like this. Banana, chocolate, chocolate. That could work. Okay. So let's start bordering off regions. So this is a region. This is a region. There's just so much freedom here. This is part of this region. So these four, so this can't be a 6 because this has to get out to here. So this is the 3. This is the 6. This is all chocolate. This is the end of the banana, meaning these are chocolate. This has to grow because bananas can't be a 1 by 1. It's got to grow down here or up here somewhere, but, well, these are all banana, and this has to grow. So there we go. There's a region. We're finishing this off quite quickly now. This is a 6-cell region because the 6 cells in the chocolate cell can't combine with anything else. The 6 cells in this banana can't combine with anything else. That's a region. And now I get what? These are chocolate because they have bordered this banana, and therefore this is all chocolate. This is a 6-cell region. And this staircase is a 6-cell region as well. So we're done with chocolate bananas. We're done with regions. So we've done the chaos construction. I just now need to do some sudoku, which shouldn't be that hard, but I'm sure it will be. This is not 6. These are 1, 3, or 4. 5, 5. You get a 5 up here. Where's 5? It's down here. Where's 5 in this region there? In one of these spots. Ones. No. Well, actually, I get 5 and 1 in here, which is not nothing. There's no 2s anywhere. So 2s are just whatever is left. Well, what could A possibly be? It's not 1, 5, 2, 4. It's 3 or 6. And it can't be 3 because of this. So A is 6. Now that's not 6. That is, what do I have left for 6s? Here and here. 6s are done. 5s. I think I have as much as I can do on 5s. I don't have much of anything else. What? How is this going to work? This is surprisingly challenging. This is not 1. That's kind of hard to see, so let me explain that. Why did I put a 1 down here? It's because if I think about where are the 1s in the first 3 rows, well, they're not in there, and they're not in here. One of them is in here. One of them is in here, so it's kind of like a virtual X-wing on 1s. Virtual's not the right word there. I don't know what the correct word is there. But I have a sort of pseudo X-wing here, which means like in these 2 rows, my 2 1s are accounted for. So these can't be 1 either. So in this, so my 2 rows in rows, my 2 1s in rows 2 and 3 are in these cells somewhere, which means my 1 in this weird box, the Sudoku box, are in one of those 2 spots. Oh, this 3. Get a 1 down here. These are from 1, 2, and 4. 3 or 4. Probably need more with 3s now. Yeah, this is a 3 in this region. It's the only place that could go. I get... No, it's all... I get 3s in there, which I can't do more with. That's 2 or 4. These are 1 and 5, which means these are 2 and 4. I wonder if I can get rid of this being a 4 somehow, but I'm not sure how yet. These are 1, 2, and 4. This is 3 or 5. Oh, but it's not, wait, no. 3 or 2, sorry. 3 or 2. 3s I can't do more with. 1s I can't do more with. Who would have thought this could be the hardest part of the puzzle? For me at least. No, I had some harder parts. Probably, well, we'll see. I haven't done it yet. Maybe I'll never finish. 1, 2, 4, 5. I hope I don't have a mistake somewhere, but we'll find out sooner or later. Yeah, this is not helpful. This cell is interestingly placed. So what is going on with this cell? Where does it go? It's got to go here because, so this cell has to appear twice in these 2 rows. Once will be in this box. The other one can't be in this box at all, so it's got to be here. So these are the same, which I'm going to label as A. A is going to go down here somewhere. A is one of these because it's 2 or 4. A is also one of these because it's 2 or 4. But I run out of room there. So let's call this B. B is in one of these spots. And one of these spots. Yeah, unfortunately, I think that's as much as I get. Whew, what am I supposed to do here? Oh, I have a 3 in one of these. So I have a 3 in one of these. I wonder if I'm just going to have to mark this up because I don't see what I'm supposed to do here. This digit, well, these 2 digits go in those 2 spots. Maybe I should just label, because I have 3s basic, well, no, not basically done. 6s are done. I have A and B here. Let's call the 1s and 5s C and D. Then D, this is a DB combo. And then A, this is AC3. So A or C does not show up here. It shows up in one of these. So these, hold on. B, yeah, the problem is B and D is 1, 2, 4, or 5, which could be any of these. Well, this can't be A. There we go. This can't be A because then A would be completely devoid in this region. So this is in fact C. That, which means what? C is 1 or 5. C, 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 C. Any of these. Well, not this one, I guess. if this could not be D for some reason, that would be really helpful because it would force 1 and 5 over here. So let's just think about what happens if that's D. We get that's D. But I think that's the end of that line. Okay, so that's possible. What if there's a problem with that not being D? So if this isn't D, we get 1, 5 specifically here. Which makes this B. Oh, so this is a BD pair, which is kind of weird. Yeah, this is a BD pair. So why is that? If this is D, what's D? If it's not D, then it's not C and it's not D, so it's not 1 or 5, which means my 1, 5 go here. But then I have 1, 5, A, 3, and 6. The only thing left is B. So this is either B or D. So now I have CBD and 6, 6 BCD. What I'm left with is 3 and A. So A is up here with 3. Maybe I should do that. This is a 3A combo. Bring the yellow back. This is so confusing. And so this one is this one. Should I call it purple or something? Like it's getting, I have so many markings. Yeah, I have no idea what to do here. I feel like I've gone astray with too many this is that's. If this is A, it's 4. If this is A, it's 2. Let's start with that. If this is A, it's 2. And then A, and then B would be here. So if this is A, this is B. So if this is A, this is 3. So where would B be in that case? If this is A3, B would be up here. So B is one of these. Of course it is. So this is 1 in A. Well, I guess I know what this is, right? So this is therefore 3, no, B and D. This is 3 and A. Yeah, which is just so not helpful. Well, do I get something weird with this? Like if this is 4, then that's 3 and A is 2. Wait. If, what did I say? If this is 4, this is 3, this is A, which will be 2, which means this is 2 or 3, but that makes B 4. Right, because A is 2, of course. B is 4, A is 2. No, this is way too much. Do I know if this is, so I can figure out if this is one of CD or one of AB, that would be hugely helpful. Could this be B? It can't be A. Could it be B? If it's B, well, if it's B, it's 4. Yeah, that's okay. Could it be A? No, it can't be A. Could it be? Okay, let's think. Could this? Where is C between these two? Could this be C? If it's C, it's 5. Could it be D? Also 5? I think probably. Yeah. Wow. I think I've spent 10 minutes at like this exact screen. Um, okay, let's rethink about this without these markings. I think they're confusing me more than helping me at this point. I do want to know that those are both C. Oh, and I have those. Let's keep those. Well, that's all of them. Gosh. Oh, I can't get rid of the markings. They're too beautiful. Okay, let's think about this cell. Could this really be 4? If it's 4, then it's B. Well, let's go back. This is 3A. I like that. I like that as well still. Could this be A? I'm just going back and forth because I have no idea what to do here. Could this be A? If it's A, it's 4. Ah, no. It can't be A. There we go. This can't be A. I probably already knew that somehow. Yeah, because if this is A, this is 3, and this is A, which will be 2. So if this is 4, it's B. Wow, that does so little. So maybe it can't be 3. If that's 3, these are A, which are now 4. Oops. Ah. If this is 3, these are A, which is now 4. That works nicely too. This all works so nicely. How? What am I missing here? This is this. Maybe I haven't fully investigated that. Which is, this is this, which is one of these. Which is one of these. I mean, and then it gets even more ridiculous than it already is. Yeah, maybe this, I'm essentially going, okay, from these 4 cells, extrapolate out, but maybe that's the wrong way to do it. Maybe I should pick a different set of 4 cells. I don't know which cells it would be. I mean, these 2 are these 2. That is very obvious. And it feels like that should be the next step. So yeah, I'm going to get rid of these markings. I don't think they have not so far yielded any results. Nope. I'm going to instead focus on this, which I'm going to call A and B, which are these 2. Let's call this C and this D now. A is not 3. I know 3's up here because of this. So we have A, B, C, 3, and D, I guess we'll have at some point. Yeah, so this is 3 or D. Now A in this box goes here, which we already knew. Which means these are a B-C combo. Which means C goes here, which we already knew. C, because now we don't know at all what C is. A, we know is 1 or 5. If it's here, it's 5. But we've already done that. I know 5's up here. I know 1's down here. This is 3 or 4, but I don't think that means it's 3 or D. Or is there any? No, these can't both be 4. So if this is 3, or if this is 4, it's B or C. So this cell. Oh wait. If this is 4, that's 3, that's D, which will be 2. 4, 3, 2. 1, 2. If this is 4, this is 4. And D is 2, so this is 4. This is 4. This is 4. So if that's 4, it's B. That fits. I don't understand. I don't understand. This is D. This is 3 or D. I mean, I ended up basically in the same place. These are 1, 2, or 4. 2 and 4 are not lettered. C could be here, or it could be 1 or 5. No, this is not the way. I don't know what the way is, but it's not this. These two are these two. These 3. And this is 3 has to go in here. 1 has to go in here. No, 5 has to go in here. 1 has to go in here. 3 is in here. I'm going to stick to numbers, no letters. This is a 2-4 pair. This is a 1-5 pair. This is a 2-4 pair. This is 4 or 5. 1's in here. Whoops. This is here, right? Because these digits, this 2 or 4 is up here. So it's not this. So this is this. Did I ever think of that? Actually, that might be new. This is one of those, is one of these, is one of these. No. Not helpful. Could this be this, be this? Then they're 4. 3. I mean, at this point, I can basically do the rest of the puzzle in my head and just see if it finishes. But that does not feel good. Actually, I'm not sure that I can, as I say that. I don't know. What am I supposed to do here? Is it something just like, could this not be 3 because it breaks something? So I mean, this does a lot of work here. Those are 3s. That places 5s. Where does it place 5s? Anywhere interesting? I don't know. This becomes A, which becomes 2. What was A? So if these are 3s, this is 2. this is 2, and this is 2. Because like this pair is this pair. Oh, that means this is this. I don't think I knew that before. Right, if these two are these two, and these two are these two, so why are these two these two? I figured that out before. Why can't this be up here? I'll put it here. Oh, right, because we'll put it here in this. Wait. No. No, it wouldn't. All right, let's go back. I don't know how I got there, but this is A, this is B. Then B goes here. So this is A, and this is B. These might be different than I had them before, but I'm going to stick with it. A now. Yeah, this cell, oh, that's what it is. This cell has to go up here. And this cell also has to go down here now. And since it's here, it's those. So yeah, so this did end up being the same. But these two cells are these two cells, which means these two are the same cell. I'm going to label those purple. That seems like new information to me. That these two are the same. So now if I have 3s, I get 2s here. How does this finish? Here. And then 4s everywhere else. 4. I guess I don't know how that works out. 4. And I get an unresolved 4 pair like that. I mean, that's so much to look ahead. What am I doing? There's got to be something. But now I've been looking at this exact screen for 20 minutes. And I don't know what to do. My sudoku is failing me. Let me just reread the rules. Oh, banana balance. I literally called this that the sum of the shaded cells will be equal. Oh my goodness. Okay, sorry. Okay. These are 21. These are 20. Well, these cancel each other out. This is 21, and 6 more is 27, and 6 more is 33. So we have 33 plus those is equal to all these yellows. What did I just say? I just lost it. That's 12, and 21 is 33. 33 plus those is these. 33 minus 10 is 23. Minus 10 is 13. Yeah, there we go. 3. Yeah, wow. So these 4 cells, yeah, this is of course it. These 4 cells, which I'll label orange, are the same as those 2 cells, which I'll also label orange because they're in different bananas versus chocolates. So then that's actually 6, which means that's going to be 5. Because if it's 1, that's definitely less than that. So this is 5. This is 1. So this is 6, 1. Yeah, 6 and 3 makes 9. 5 and 4 make 9. If I flip these two, it doesn't work. So this is 4, this is 2. Wow, I'm so sorry. I spent 20 minutes on absolutely nothing. I'm so mad at myself. But it's okay. C'est la vie. These are 3, 4, 5. These are 1 and 2. These are now 1 and 4. These are now 3 and 4, though. So this is 3, this is 4, this is 3. This is a 2, 5 pair. This is not 4 now, that's a 5. 2, 5. This is a 1, 2 pair. This 2 looks here at this 1, which makes this 2, and this 4, and this 1, and this 2. This is a 5, this is a 4, this is a 3. Holy cow. I feel so silly. But there it is. Once you think of the rule, it all comes into place. So thanks, Paddling Penis, for setting that. And thank you for watching. And yeah, I'll see you all next time if you ever come back. Bye.